So I think at this stage we can take another poll.
Yep. You can now start entering your vote for question 3. We'll give it a few minutes for the audience to enter the vote.
So question number 3 is when does your network operations deploy or plan to deploy 40 gig and beyond in the networks? And this sort of comes back to the what I was talking about around the ability for tools to be able to handle large amounts of traffic, not just from multiple network segments, but obviously from very large bandwidth network links and segments themselves.
Mm-hmm. Just a few more minutes. More votes are still coming.
Very good.
In addition to entering your vote, you can also enter your questions now if you like, and we will answer them at the end of the presentation, usually the last 15 minutes of the session.
Yeah, thanks for that, Anna. That's good. Okay, so I think the votes are stabilized now.
Yep.
Yeah, I noticed,
so here are the results. When does your network operation deploy or plan to deploy 4G and beyond networks? We have 18% answering already deploy 4G, 9% answering first half of 2014, 18% answering second half of 2014, 14% answering skipping 40G and go to 100G, and 41% answering sticking with 10G for a while.
Yeah, this is also very interesting, Anna. This sort of gels very well with the view that we've had of the industry at this point in time, where yes, the majority of people still are running 10 gig, possibly even 1 gig, and they're going to stick to that for some time yet. But it is interesting to see that there's quite a bit more 40 gig coming in to deployment than has been in the past. And also very pleasing to see that there are a lot of organizations looking to jump straight to 100 gig. We knew there were a few, like a very low percentage, but actually 14% is higher than I expected. So that is quite interesting to see. Okay, so and the one thing from that obviously is that it's going to increase the importance of what I was talking about on the previous slide. We move on to the next slide. So what we can actually do with the network architecture is we can even make some modifications using the network packet brokers to not just have scattered tools all over the place and maybe regionally located to provide some more manageable or seemingly more manageable and scalable solution, but to actually have implemented a network packet broker solution running as a complete system, which allows the traffic from the various segments and the various links to be brought together and forwarded back to a more centralized location, where you can actually then, from a single point, you may want to have more than one location, but it's really up to how you want to run your organization. For instance, you may have a network operations center versus a security operations center, and then that's perfectly fine. But at least you can bring all the traffic back to a centralized security operations center and use your network packet broker system, which can consist of multiple network packet broker appliances, bring that traffic back to that centralized location to do security monitoring. And if you have a separate location for network monitoring, then you could actually bring it back to that point as well. And then you can still make use of the various grooming techniques to filter traffic, to only send traffic of the specific types to the tools that need to see that specific traffic. And then it also gives you an additional power to, instead of deploying very expensive devices all over the place, you can actually start to think more holistically or more centrally about how you want to manipulate the traffic that's being sent to the devices. A good example is if you want to do some voice traffic analysis, you probably don't need to look at all the payload, which does make up the majority of the volume of the traffic within the voice over IP network. In such a case, you can actually remove the payload traffic that's being sent to the voice over IP monitoring tool, and by doing that, then you reduce the amount of traffic you need to send to that tool, which reduces the load on the tool, as well as also reduces the load on the backhauling requirement. Other situations could be in a security aspect where you're interested to know what's going on and who's communicating on web applications, but you don't necessarily need to know specifically what's in the content. And so, as such, the amount of traffic that you need to send to them, you can actually remove the large percentage of the actual payload that's being sent, because a lot of the analytics don't necessarily need to see the payload. They're more concerned about knowing who, what, and where has been going on with the communications, not so much exactly what the content of that communication has been. Okay, so we'll move on to the next slide. And so this is showing, it's showing the situation for using network packet brokers, which is often using the acronym nowadays called NPB, for actually helping to scale your architecture. And this is showing how you can actually interconnect your network packet brokers as a kind of a middle layer between the network itself, which has got the traffic, and then the tools that you're using for your network performance monitoring, application performance monitoring, or security monitoring solutions. And it could even be for storage as well. There's so many different types of needs out there for being able to monitor and store the traffic. So this middle layer can provide that entire system, which contains redundancy and some self-resiliency to make sure that if you're taking traffic from one or several points on a network and you want to get it to one or more different types of tools that you need to do the monitoring on, that you will continue to get the traffic across to those points, no matter what happens within your monitoring infrastructure. Even if one port goes down or one network packet broker loses power or something like that, you can then alternatively send the traffic through a different route to actually get it to the tools that you need to get it to. And as I mentioned before, it's not just to get it to the tools, it can even be just to get it to a storage location that can be used either for archiving, could be used for compliance reasons, or could be used for multiple different diagnostics or troubleshooting tools to get access to that data at a later date. And this here is actually quite focused on a kind of an inline security application. And inline security applications are more unique than passive monitoring applications in that your monitoring tool needs to be placed inline in the network. And as I mentioned earlier, having contention for access to the points or links or segments in a network is one issue, where if you have more than one type of tool to look at different types of aspects of the traffic, then you need to connect them all in series, which then, of course, introduces multiple points of failure in your network. So that's one obvious challenge. The other, of course, is also around this asymmetrical routing problem, or even it could be link aggregation, where you're actually trying to treat multiple links as one aggregated link group, or trunking type of feature. You don't, just by getting access into one link, or maybe a couple of links, you don't necessarily see all of the traffic associated with a particular session. So what we're showing here is the way to use a network packet broker and an inline application to address both of those issues. One is you only use the network packet broker as a single point in breaking into that link, and then you can interconnect as many different types of tools as you need onto the packet broker to forward the traffic to them as you need to do the monitoring. It also allows you to single out the specific types of traffic that each of those tools needs to see, thereby reducing the possible load or irrelevant amounts of traffic that get sent to those tools, therefore making them function more efficiently. And at the same time, the network packet broker can do checking on the health and the status of those tools to maybe take action, to bypass them altogether, to maybe switch over to redundant backup tools, and definitely provide some form of alerts to the network or the monitoring administrators. And so this will increase your resiliency, and as we described before, the network packet broker's ability to aggregate multiple links at the same time, you can now bring together multiple inline links, forward them across to the tools, and spread the load across multiple instances of the same tools to ensure you get full visibility into all of the traffic, and most importantly, to get all the packets associated with a given session, to be able to monitor it successfully for, and not just for some kind of performance needs, but more importantly for some security aspects, to make sure people are not having networks being attacked, and also that possibly sensitive data is not actually being forwarded outside an organization, which is also very critical and a big concern for people these days. And the other thing that can also be provided is you can, with this type of configuration, you can provide some high availability by having more than one network packet broker connected into networks, and providing backup monitoring if, say, a tool set goes down on one location, or if the power is lost in a particular location on one part of the data center, then another part of the data center can stay up and continue to monitor the network. There's a number of different scenarios you can play out here by making use of these intelligent inline network packet brokers. So ultimately what it comes down to is it actually allows you to reduce the actual cost that you have of the initial expenditure that you need to put in place to do the monitoring for your performance or your security needs. It also reduces the complexity, as well as the operational cost of continuing to maintain and run and monitor your networks. And that's largely because, okay, you're not going to have isolated, orphaned tools sitting out in different locations that you have to try and manage somehow. You will actually get access to and visibility to every single point in the network that you need to get access to, and see all of the traffic that you need to see. And because it's bringing it, because the network packet brokers function as one system cohesively, you can connect your and have your devices sitting in a more centralized location. You can much more easily manage the direction of the traffic and the access to the traffic in those parts of the network, and get more complete visibility into the actual traffic on each of the tool instances that you have. And so, obviously, cost of ownership is one thing, and then return on investment is a very key item. And being able to address your needs to get access to traffic on the ever-changing network traffic volumes as well as network speeds is a critical item.